Alright, in this video, we're going to look at some basic antiderivative rules. The first one is the power rule for indefinite integrals. So the power rule says the integral of the function x to the power of p dx, where p is any number except 1. The result is the function x to the power of p plus 1 over p plus 1. So this formula tells us the antiderivative of the function x to the p will be the function x to the p plus 1 over p plus 1. Why? Because if we take the derivative of this function, so when we take the derivative of this function using the power rule of derivative, we will get p plus 1 times x to the power of p plus 1 minus 1 over p plus 1. Now the p plus 1 and the p plus 1 are cancelled out. The exponent is p, right? So that's why the antiderivative of the function x to the p is this function is x to the power of p plus 1 over p plus 1. Okay. And sorry, so x, sorry, p should be not equal to -1, not +1. The reason p cannot be -1 is if p is -1, the denominator gonna be 0. Right? Okay. Let me do a few examples using the power rule. Like to find what is the antiderivative of the function x to the 8. Okay, again, we said to find the antiderivative is to think which function. Okay, which function. When we take the derivative of that function, we can get x to the 8, right? Now, using the power rule, now the power of xp is 8, so the result gonna be x to the power of 8 plus 1 over 8 plus 1, and plus a constant, because any function x to the 9 over 9 plus a constant, the derivative of that function is x to the 8th. Right? So the result is x to the power of 9 plus a constant. Okay. Now let's take a look at another one. Now 1 over x to the 4th dx. Just like when we use the power rule of derivative, we said before we use the power rule, we need to write the function into the standard form. Standard form means the function has been written into x raised to the power of some number. Now, because here we have a 1 over x to the positive 4. Now, when we write the function, this function into the standard form, it will be x to the power of -4. Right? So in other words, here the p in the formula, the p is a -4, is not +4. Okay. Now using the power rule, we can find the antiderivative, which is negative 4 plus 1 over negative 4 plus 1. So the answer is x to the power of negative 3 over negative 3 plus c. Okay. And we can keep simplifying this function and write as negative 1 over 3 x to the power of 3 plus c. Okay. All right. The second rule is a constant multiple rule. It says the integral of the function c times fx dx is equal to c times the integral of the function fx dx. So this tells us the antiderivative of a constant times a function is equal to the constant times the antiderivative of that function. Like the integral of 2 times the square root of x dx. This equals this constant 2 times the integral of the square root of x dx. Okay. Now to find what is the antiderivative of the square root of x, we can use the power rule. But before we use power rule, we have to rewrite the function into the standard form. The square root of x is x to the power of 1/2, right? Then using the power rule, the antiderivative of x to the power of 1/2 gonna be x to the power of 1/2 plus 1 over 1/2 plus 1, and then multiply by this constant 2. So this will be 2 times x to the power of 3 over 2 over 3 over 2. So that gives us 4/3 times x to the power of 3 over 2 and plus c. Okay. Remember, we have we need to add this constant because the indefinite integral, it gives us the family of antiderivatives. Okay. Okay. The sum and difference rule says the integral of a sum or difference of two functions equals the sum or difference of the integral of the two functions. So now let me do 2 more examples using these 3 antiderivative rules. Okay. So the first one, we are looking for the integral of the function 3x to the 4th minus 5 plus x to the power of 3 over 4. Now here we have a difference and a sum of some functions. So we first use the sum and the difference rule. So we can write this as the integral of 3x to the 4th dx minus 5 dx and plus the integral of x to the power of 3 over 4 dx. And then use the constant multiple rule. We can bring this constant outside of the integral sign. So we have 3 times the integral of x to the 4th minus 5. Now, some students wonder, after we move the phi outside of the integral, what do we have inside? Now inside we should have 1, right? And 1 we can write 1 as x to the power of 0. Now this is a very common trick we use. So when we have the integral of 1 dx, we write this as the integral of x to the power of 0 dx. So the p in the power rule, the p is 0 in this case. Okay, just remember this. Okay. And for the third one, since there's no constant, so we leave it. Okay. And the next, for each integral, we use the power rule. So we have 3 times x to the power 4 plus 1 over 4 plus 1 minus 5 times x to the power of 0 plus 1 over 0 plus 1 plus x to the power of 3 over 4 plus 1 over 3 over 4 plus 1 and plus c. So we have 3 over 5x to the power 5 minus 5x and plus 3 over 4 plus 1, that's 7 over 4. So it's 4 over 7 times x to the power of 7 over 4 plus c. Okay. All right. For the second one, so first we need to split this function into the sum of two functions. Okay, and then use the sum and difference rule. We can write this as the integral of x over the square root of x dx plus the integral of 1 over the square root of x, 1 over the square root of x dx. And the square root of x, we write them into x to the power of 1/2. Okay, then after we use the property of exponents, the first function we can write as x to the power of 1/2. And the second function we can write as x to the power of negative 1/2. Then for each function, we use the power rule. So we can find the antiderivative, which for x to the power of 1/2, the antiderivative is x to the power of 1/2 plus 1 over 1/2 plus 1. For the function x to the power of negative 1/2, the antiderivative is x to the power of negative 1/2 plus 1 over negative 1/2 plus 1. So the result is 2/3 times x to the power of 3 over 2 plus 2 times x to the power of 1 over 2 plus c. Okay. The antiderivatives for the trigonometric functions, we can derive them from the formula of the derivatives. Like since the derivative of sine x is cosine x, therefore the antiderivative of cosine x is sine x. So the integral of cosine x dx is sine x plus c. And since the derivative of cosine x is negative sine x, therefore the antiderivative of sine x is a negative cosine x plus c. And the antiderivative of secant square x is tangent x plus c. The antiderivative of secant x times tangent x is secant x plus c. And the antiderivative of cosecant x times cotangent x is negative cosecant x. And the antiderivative of cosecant square x is negative cotangent x plus c. Okay. And for the exponential function, with base e, the antiderivative is the same as the function. Okay. Because we said the derivative, since the derivative of the function e to the x is e to the x, so that's why the antiderivative is the function itself. All right. So now let's use these formulas to solve this problem. So first, we can write this as the 1/3 times the integral of cosine x dx minus the integral of ex dx and plus the 2 times the integral of secant square x dx. So here I'm using the sum and difference and the constant multiple rule. Okay, and then the antiderivative of cosine x is sine x. So the first result is 1/3 times sine x. And for the second term, the antiderivative is e to the x, so minus e to the x. For the last term, the antiderivative of secant square x is tangent x, so it's 2 times tangent x, and plus the constant c. Okay. All right. In the next video, we're going to look at what is an initial value problem, and how to solve the problem.